This topic is about problem solving with differentiation. I will go through 6 examples. Feel free to pause as and when you need to. So figure 3 shows a flower bed. Its shape is a quarter of a circle of radius x with 2 equal rectangles attached to it along its radii. Each rectangle has length equal to x meters and width equal to y. Given that the area of the flower bed is equal to 4 meters squared, so start off here. So A is equal to, so we know A is equal to 4. That's the first thing we know. Show that Y is equal to that. So if I were to work out the area another way using formulas, then I know it's the area of all the different parts. So it's going to be XY here, XY here, and this is equal to a quarter of pi r squared, but the radius is x, so it's going to be a quarter pi x squared. So if I put that together, I get area is equal to quarter pi x squared plus xy, which implies that area is equal to a quarter pi x squared plus 2xy. If we put the first line, the last line together, I get a quarter pi x squared plus 2xy is equal to 4. Okay, which means I need to make y the subject of the formula. 2xy is equal to 4 minus a quarter pi x squared. I don't like the quarter, so I'm going to multiply through by 4. So if I multiply 2xy by 4, I get 8xy. If I multiply 4 by 4, I get 16. And then a quarter multiplied by 4 gives me just 1. So I'm just going to get minus pi x squared. If I divide through by 8x, I get 16 minus pi x squared over 8x, which is what I wanted. So that's 8a. Okay, part B now. Hence show that the perimeter is given by this formula. Okay, so perimeter is x plus y plus y. This is going to be a quarter of 2 pi r. A quarter of 2 pi r, which is a half pi x. This is y. This is x. And this is y. So the perimeter is going to be y plus x plus y plus half pi x plus y plus x plus y. If I collect the like terms, I get 1, 2, 3, 4 lots of y plus 2 lots of x plus half pi x. The whole point is I want to eliminate the y. So let's call this 1. So P will be equal to 4 lots of 16 minus pi x squared over 8x plus 2x plus half pi x using 1. Okay, so I need to simplify somehow. P is equal to 4 over 8x gives me a half. Let's just separate it out actually. 4. So 4 over 8x leaves me with a 2 at the bottom. So I can have it as 16 minus pi x squared. So the 4 cancels out here and that becomes a 2. So it's going to be 2x plus 2x plus a half pi x. 16 over 2x is equal to 8 over x. Minus pi x squared over 2x gives me minus a half pi x plus 2x plus a half pi x. So this term and this term cancel out. So perimeter is equal to 8 over x plus 2x, which is what I wanted. use calculus to find the minimum value of p. Okay, C, so I got p is equal to 8 over x plus 2x. So p is equal to 8x to the minus 1 plus 2x. So if we differentiate p with respect to x, I get minus 8x to the minus 2 plus 2, which can be rewritten as 2 minus 8 over x squared. At minimum, we know dp dx is equal to 0, which implies 2 minus 8 over x squared is equal to 0, which means 8 over x squared is equal to 2, which means x squared is equal to 8 over 2, which is 4. X must be positive, so x must be equal to square root of 4, which is equal to 2. The units are in meters, so 2 meters. So the perimeter will be, which is 8 over x plus 2x, is equal to 8 over 2 plus 2 times 2, which is to 4 plus 4, which is 8 meters. Okay, find the width of each rectangle. So use calculus to find the minimum value p. We've done that. D, find the width of each rectangle when the perimeter is minimum. So we know y is equal to, so y is equal to 16 minus pi x squared over 8x. So y will be equal to 16 minus pi times 2 squared over 8 times 2, which is equal to 16 minus 4 pi over 16, which is equal to 1 minus a quarter pi, which is equal to 0.2146, blah, blah, blah. And it was measured in meters, which is equal to 21.46, blah, 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 centimeters. If I had to round it to the nearest centimeter, it is approximately 21 centimeters. Okay, next question. Figure 4 shows a closed letterbox A, B, C, D, E, A, B, F, E, H, whatever, which is made to be attached to a wall of a house. The letterbox is a right prism of length y, shown as figure 4. The base A, B, F, E of the prism is a rectangle. The total surface of area of the 6 faces is S. The cross-section A, B, C, D of the letterbox is a trapezium with edge length 9x, so it's basically figure 5. The angle DAB is 90 and angle ABC is 90. The volume of the letterbox is 96,000. That's important, so let's write that down first. So V is equal to 9,600, sorry. Okay, show that Y is equal to 3,200, so on. So first thing is volume is equal to area of cross-section. Area of cross-section times length. So area of cross-section is this one, which is the area of cross-section for this is going to be A is equal to half A plus B times H, which is equal to, this is A, this is B, and this is H. So half of 9x plus 6x times 4x, which is equal to 15x times 4x, which is 60x divided by, which is going to be 30x squared, sorry. So 15x times 4x is 60x squared divided by 2 is 30x squared. Okay, and the cross-section is, area of cross-section is 30x squared times the length is y. So V is equal to 30x squared y. Now, equation 1, equation 2. So when we combine 1 and 2, we get 96,000 is equal to 30x squared y. So y will be equal to 9,600. I keep saying 96,000. 9,600 divided by 30x squared. 9,600 divided by 30 gives me 320 over x squared, which is part A done. Part B. Let's just keep this bit separate. Part B. Hence show that the surface area of the letter box S is given by S is equal to blah, blah, blah. Now the surface area is going to be the surface area of all the faces, okay? So this is, I need to work out all the faces. So the top face is going to be, this one is Y, this is Y, and this is 5x. So the top one is 5xy, 5xy. The bottom one is Y times 4x. Y times 4x is this is 4x. So it's going to be 4xy at the bottom. So this is 4x. Okay, this one's going to be 6x. This is 6x. So it's going to be plus 6xy. And this one's going to be 9x times y, which is 9xy. Okay, and the trapezium we've already worked out. We've got 2 trapeziums, so plus 2 lots of 30x squared, because each one is 30x squared. We've worked it out. So S is equal to 5x plus 4x, 9xy, 18xy, 24xy, 24xy plus 60x squared. Okay, S is equal to, if we replace the y with 320 over x squared, that's 60x squared. S will be equal to 24x times, and one of the x's cancel out. So all we're left with is 7680, which is 24 times 320, over x plus 60x squared, which is the same, which is what we wanted. See? Use calculus to find the minimum value of S. So ds dx, if you rewrite this, is 7680x to the minus 1 plus 60x squared. I don't know if this was clear, but this was also 9x times y. Okay, ds dx is going to be minus 760 minus 7680. Let's rewrite that again. So differentiating s, I get minus 7680x to the minus 2 plus 120x. So we know at minimum value, ds dx is equal to 0, which implies minus 7680 over x squared. We can write x to the minus 2 as over x squared plus 120x is equal to 0. If I times through by x squared, I get minus 7680 plus 120x cubed is equal to 0, which means x cubed is equal to 7680 divided by 120, which is 64. So x will be the cube root of 64, which is equal to 4. Because it was using centimeters, x will be 4 centimeters. What we're trying to find next is minimum value of s. So when x is equal to 4, s will be equal to 60 times 4 squared plus 7680 over 4, which is equal to 2880 centimeters squared. Part D says justify by further differentiation that the value of S that you have found is a minimum. So I need to differentiate again. So dx squared. Okay, minus 7, so I'm differentiating this. So minus 7680 times minus 2 gives me 15360 x to the minus 3 plus 120. So I need to find the value of this when x is equal to 4. So it'll be 15360 4 to the minus 3 plus 120, which gives me a value of 360, which is greater than 0. Therefore, because it's greater than 0, that means the minimum, sorry. Therefore, minimum occurs when x equals 4. Therefore, minimum S is equal to 2880 centimeters squared. Okay, next question. Figure 4 shows a plan of a pool. The shape of the pool ABCDEFA consists of a rectangular BCEF joined in to an equilateral triangle BFA and a semicircle CDE as shown in figure 4. Given that AB is equal to X and EF is equal to Y meters and the area of the pool is 50, so A is equal to 50, that's the first thing we do know. Show that Y is equal to blah, blah, blah. So A is equal to 50, but A is also equal to area of all the sections added together. This is obviously X times Y, so this is X times Y. This is going to be half a semicircle, so it's going to be pi r squared divided by 2. So pi r squared divided by 2 is pi. R will be the half of X, so it's X over 2. Pi r squared divided by 2, which is half. So half pi X over 2 squared. And an equilateral will be, because I know this is equal to pi over 3, then, and this is also equal to X, then half AB sine C tells me this is half X times sine pi over 3. So the area of this will be equal to XY plus half pi X over 2 squared plus half X squared sine pi over 3. Now sine pi over 3, if you put that into your calculator, is equal to root 3 over 2. Which means that simplifies to xy plus pi over 2 times 2 squared, which is equal to 8 pi over 8x squared, plus I get root 3 over 4x squared. If I combine using 1 and 2, if I combine them together, 1 and 2 together implies xy plus pi x squared over 8 plus root 3 over 4x squared is equal to 50. Okay, I need to make y the subject of the formula, so xy will be equal to 50 minus pi x squared over 8 minus root 3 over 4x squared. Okay, if I want to write the last two terms, put these two together, then I need to time the top by 2 and the bottom by 2. So I end up getting xy is equal to 50 minus pi x squared over 8 minus 2 root 3 over 8 x squared, which means I can factor out the x squared over 8, and inside the bracket I get pi plus 2 root 3. Okay, the last thing I need to do is divide by x. So I get 50 over x minus x squared over x will just give me x, which gives me x over 8 pi plus 2 root 3. And that is what I wanted. Okay, part B. Okay, B. Hence show that the perimeter P of the pool is given by this. Okay, perimeter is equal to, if I go around, this is y, this is y, this is equal to half 2 pi r. So it's going to be half times 2 times pi times r is x over 2. half x. Yeah, so that part. This is x and this is also x. So the perimeter is equal to x plus x plus y plus y plus half times 2 pi times a half x, which simplifies to 2x plus 2y plus, you get half times half, which is a quarter. 2 over 4 is a half pi x. So if I want to get rid of the y, because obviously this does not have y, so that means p is equal to 2x plus 2 lots of 50 over x minus x over 8 times pi plus 2 root 3 plus half pi x. Apply out the bracket, I get p is equal to 2x plus 100 over x minus 2, so 2 and the 2, so the 2 cancels out with the 2 at the bottom, which gives you a 4. So minus x over 4 times pi plus 2 root 3 plus a half pi x. So what I do know is I can combine these two because there's an x in common as well. So I need to times this by 2, which means I need to times this by 2 as well. So I end up getting p is equal to 2x. P is equal to actually this looks very long, so what I'll do instead is I'll instead multiply out the bracket. So I get 2x plus 100 over x minus pi x over 4 minus 2 root 3x over 4 plus a half pi x. Okay, what I realize is the 2 cancels out and I'm left with 2 there. Okay, so that means I've got p is equal to 2x plus 100 over x minus root 3 over 2x. Now these two terms, minus a quarter pi x plus a half pi x gives me a quarter pi x. So it's going to be plus pi x over 4. If I rearrange it and keep the 100 over x separate, then I've got plus 2x plus pi x over 4 minus root 3 over 2x. If I write everything over 4, because I need everything over 4, then I get, so there's an invisible one here, so I need to times this one by 4, which means I need to times this one by 4. If I times this one by 2 to make the bottom 4, then I need to times this one by 2 as well. So what I end up getting is p is equal to 100 over x plus 8x over 4 plus pi x over 4 plus 2 minus 2 root 3 over 4x, which means I can factorize out the x over 4 and then end up getting inside the bracket x 8 plus pi minus 2 root 3, which is what I wanted. So I can rewrite it as p is equal to 100 over x plus x over 4. Let's write it the way they have it, pi plus 8 minus 2 root 3. And that is it. Okay, so next part is C, use calculus to find the minimum value. Okay, so C Let's do it here. So C is equal to dp dx. So this can be rewritten as 100x to the minus 1 plus a quarter x times pi plus 8 minus 2 root 3. So when I differentiate with respect to x, I get minus 100x to the minus 2 plus a quarter times pi plus 8 minus 2 root 3. So at minimum, dp dx is equal to 0, which implies minus 100 over x squared plus a quarter times pi plus 8 minus 2 root 3 is equal to 0, which means minus 100 over x squared is equal to, no, let's rearrange it the other way. So take this over to the other side. So I get 100 over x squared is equal to quarter times pi plus 8 minus 2 root 3. Okay, if I swap it over, then I get 100 over quarter times pi plus 8 minus 2 root 3 is equal to x squared, which is the same thing as square root of 100 over a quarter times pi plus 8 minus 2 root 3 is equal to x. And we're going to take this positive square root because its x is a length, which gives us x is equal to 7.21805 blah blah blah. And we want it to 3 significant figures, so x is equal to 7.22 meters. Now we didn't want, actually, this is where most students make a mistake. We didn't want to find x, we're trying to find the minimum value of p. So what we do need to do is substitute back into p. So that means p is equal to 100 over 7.21805 blah 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 plus 7.21805 blah 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 over 4 times pi plus 8 minus 2 root 3, which gives us a value of 27.70828 on our calculators, which is equal to 27.7 meters to 3 significant figures. Justify by further differentiation that the value of p that you have found is a minimum. So I need to differentiate again. So this is d squared p over dx squared is equal to minus becomes a positive, so it's positive actually. So positive 200 x to the minus 3. And if I substitute x is equal to 7.218 blah blah blah, I get 200 times 7.218 blah 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 to the power of minus 3, which is equal to 0.5318 blah blah blah, which is greater than 0. Therefore, minimum occurs when x is equal to 7.218 blah blah blah. Therefore, minimum value of p is equal to 27.7